Hi, this is Math 1428, remote delivery for May 4th, 2020. We're covering content from section 8.1 and the topic is sequences in series. I'm going to remind you to use these YouTube controls to throttle the presentation and to perfect your understanding. I'm going to encourage you to don't stop believing. Hold on to that feeling. Just like the world champion 2005 White Sox, they thought they could, and so they did. So can you. You can earn a grade, and your educational goals need not be deferred. Hang in there. Today's topic is section 8.1. We're going to have these learning objectives. We're going to find terms of sequences given the nth term. We're going to look for patterns in a sequence and try to determine what is the nth term or the general term. Here it says convert between sigma notation and other notation for series. You are supposed to know about series, but the curriculum documents say we should not cover sigma notation, so I'm putting an X through that. And we will talk about recursively defined sequences, and you have to be able to construct the terms of them as well. So, what is a sequence? Well, a sequence can be infinite or it can be finite. A finite sequence is a function having for its domain a set of positive integers, 1, 2, 3, 4, 5, ... keeps on going all the way up to n, for some positive integer n. Now what this means is this is an ordered list of numbers. So there is a first number, a second number, a third number, a fourth number, a fifth number, and an nth number. But that is the sequence. It's the set of numbers. This is just the domain telling you there is an order. You can also have an infinite sequence where the domain is a set of positive integers. So there's a first number, a second number, a third number, a fourth number, a fifth number, and it never ends. We will discuss both of these in the context of what we do going forward in future sections. So these are called sequences. They're ordered lists of numbers. So here's an example. You're asked to find the first 4 terms and the 23rd term of the sequence whose general term is given by. This is a sub n. The nth term is minus 1 to the nth power times n squared. So you see, to get the first 4 terms, you're going to let n be 1 and get this, n be 2 and get this, n be 3 and get this, n be 4 and get this, and n be 23 and you will get this. Now there is a way to do this with a graphing calculator, and I'll say more about a graphing calculator later. Notice that these signs change from negative to positive, and so on and so forth. Such a thing is called an alternating series. And you know what to do and when to do it. Here's an example that will help you perfect your understanding. Now you do have to change your calculators into a different mode to do this. So you go and you press the mode button and you go through and you will change this from what normally is a function mode over to an SEQ, which is a sequence mode. And you change the graph from a connected graph to a dot graph. When you press the Y equal button after making those mode changes, after you enter the change, if you press the Y equal button, instead of having Y equal, you will get these sequences, U of n and W of n and V of n and so on and so forth. So these are what you will do, and here is how you will graph it. You do have to be concerned about your plot window. And if we do a plot window, or actually here we define a function. This is looking ahead to one we're going to be talking about. But here I define U sub n equal n over n plus 1. So you see I can press the Y equal button, I get this, and I type that in. Similarly, you can hit your window button, and the window button is here. So when you hit your window button, you say where does the sequence start and where does it finish and what are the sizes of the steps. And if you press the plot button, then you can evaluate what happens when n is equal to 5. That's the value button that comes from the calculate second and the calculate, and you'll get this, and notice the graph now is shown as dots. These are things we're going to talk about, but that's how you do these with your calculator. Okay, so here it says use a graphing calculator to find the first 5 terms of the sequence given by this, and I just did that, and I did 5, and I got 0.83333, which is really 5 over 6. If you change it to a fraction, if I did 4, I would get this, 3, I would get this, and so on and so forth. Depending on how fancy your calculator is, you can do other things, but I was showing you the general model. Here's another example, and they ask you to graph the sequence whose general term is given by this. This was the graph I actually did before you saw those dots, and so you have something that you can practice here, exercise 19, if you want to perfect your understanding. Here's my example 4. Now these are given sequences, and you're supposed to find the general term or the nth term. So you see here what we get is 1, square root of 2, square root of 3, and then 2. Okay, so you see this is 1, which is the square root of 1. This is the square root of 2. This is the square root of 3. But the square root of 4 is 2. So you see the general term here is the square root of n. So based on this, a sub n is equal to the square root of n. Now it could be different, but based on what we have, that's what we would predict. B, we look at this. So this is minus 1, 3, minus 9, 27, minus 81. This is an alternating series, dot, dot, dot. So these are powers of 3 with alternating signs. So the general term could be minus 1 raised to the n power, and this is 3 to the, and this is n minus 1. So you want to be able to do matching of these. Here we have 2, 4, 8, and you see these are powers of 10. So we can guess that what we have here is a sub n is equal to 2 to the n. Now, those may or may not be, but those fit the terms that we have, so that is how you solve the problem. Here's a problem if you want to perfect your understanding. Now we also talk about things called series, and series is when you add up the terms of a sequence. So we can have an infinite series, which you add up an infinite set of things, and we will talk about that. So that is an infinite series, but you can also have a finite series where we only add up part of the terms. We add them up in the order in which we find them. So here's an example where you're supposed to find s sub n. So this means I want to find, for this sequence, I want to find what is s sub 1. Well, that's just the first term. It's going to be minus 2. Here I want to find the first 4 terms. So I take the first 4 terms in the sequence and add them up and get 4. Here I want to find the first 5 terms if I add them up. And so I'm going to be adding up the first 5 terms, and I will get minus 6. You can try this exercise to perfect your understanding. And here you can add things up with your calculate function. And here they're talking about a kind of a fancy thing, but you should ever be able to find S1, S2, S3, and S4 by hand for this a sub n. And if you do, you would get these answers. When n equal 1, this is what's true. When I add up the first 2 numbers, I will get this. First 3 this, and the first 4, I will get this. You should check to make sure that you can get those answers. Now here is, and this is where your book talks about the sigma notation, and also example 7 and 8. I am not going to test you on those because those have been asked, but we cut those out of the 1428 curriculum, so we're not going to cover those. The last topic is we're talking about recursive definitions. A sequence may be defined recursively or by using a recursion formula. Such a definition lists the first term or the first few terms and then describes how to determine the remaining terms from the given terms. An example is worth 1,000 words. So let's look at this example. So it says that A1 is 5, but then for the rest, whenever n is bigger than or equal to 1, a n plus 1 is equal to 2 a sub n minus 3. So what we do is, for n being 2, I can take what a1 is, multiply it by 2, and subtract 3, so I get 7. When I go to a3, I have to take what A2 is, substitute it in, and I get now 11. When n is 4, A4 is equal to 2A3 minus 3. I substitute it in and I get 19. Lastly, A5 is equal to 2 A4, which is going to be 19 minus 3, and I get 35. So you see, this is the kind of question I could ask, and here's a problem that you can try to test your understanding. In fact, to perfect your understanding. Okay, let me summarize then with the path ahead in our remote delivery because we're nearing the end. Today, I did deploy this morning the Chapter 5 and Chapter 6 quiz. It's due tomorrow by 1 o'clock p.m. Our time zone. And so you should be working on that. I'll be giving you instructions as to how to submit your answers. This is not going to be self-graded and self-reported because the final is not, so we're practicing that. No one's going to get screwed. Hang in there, do the work, you will be fine. Today we also did section 8.1. On Wednesday, May 6th, we're going to talk about special sequences, and in fact we'll talk about the arithmetic sequence and the geometric series, and we'll talk about a special theorem called the binomial theorem. Those are the last three things you will learn this time, and this will be sections 8.2, 8.3, and 8.7 will happen on Wednesday. Also, I will do a readout on Chapter 5 and Chapter 6 quiz. That'll be useful as you prepare for the final exam. May 8th, our last class day, I will review for the final and tell you how that will work. And on Monday, May 11th, we will have our mandatory comprehensive final exam. It is mandatory. You will not get a passing grade in the course unless you take this. But I'm not out to screw anybody. What you really should do is do your best, and I think things will be fine. But that's the mandatory comprehensive final exam. So a lot of stuff to do. You want to finish strong. So now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. See you in